So today we are going to be looking at quadratics. Quadratics is something that you should have covered in either the academic or the applied stream in grade 10. So this should be a review or a refresher on the material, at least in this cycle, and in the next cycles we'll look a little bit at more, we'll build on our knowledge of it. But what we're going to do first is a little bit of a warm-up. So we want to use the symmetry of quadratics to help us find specific points, and the specific points that we're going to try to find on these quadratic functions are the axis of symmetry, the vertex, the y-intercept, and the zeros. So just a little bit of a warm-up. Again, we should remember that quadratics are symmetrical, so they are the same on both sides. That's what helps form this U shape and this N shape kind of that we see. So basically we're just kind of using the same points on the other, similar to like a mirror reflection activity that you may have done in elementary school. So basically this point here is down 1 and over 2, so that means there needs to be a point on the other side that mirrors that. And that's what we're going to do for all of them. So basically we're just mirroring them on the other sides, because that is the first step, or first one of the identifying factors of a function or quadratic function. It does have that symmetry. It's a little bit different from periodic functions, because this does not repeat. There is only one repetition, and that is it. Roughly sketching it out, at least for our purposes. Again, just going through and finding all those opposite points on the other side. And then just connecting them as best we can, so that we should roughly see two symmetrical sides to our parabola. Now, the next thing we're going to want to do, or the first thing, I'm going to put a red dot next to it so we know that's what we're looking for, is the axis of symmetry. So I want to find the axis of symmetry of each point, or each function. And what the axis of symmetry is, it's an invisible line that goes right through the middle of each quadratic function. So this right here is my axis of symmetry. I'll call it my AOS, just for short terms. And again, it's that invisible line that cuts my parabola in half. We just talked about how the parabola is symmetrical. This AOS is the invisible line that cuts through it, or that cuts it in half. Again, looking at this vertical line, we can come up with an equation for it. If we refer back to kind of grade 9, the vertical line has an equation of x equals, and in this case x equals 4. That's my vertical line that cuts it in half. And it's going to be the same thing for all of the other functions as well. Find where half is and draw an imaginary line right down through it. That's our AOS, or x equals, in this case, x equals 1. My second one, or my third one, again, cuts it right down the middle. There's my vertical line, it's my AOS, and x equals -3. Same thing here. Find the vertical line, and that means that it is, again, my AOS, and x equals -4. So that's the AOS. The next thing we want to look for is our vertex. And we'll talk a little bit more about vertex later, or give an actual definition of it when we get into the note, but the vertex is the point, the highest or the lowest point. So right here, I'm going to have a high point. This is going to be my vertex, and the vertex is just a point. So remember, your coordinates are x and y. So this means the vertex is 4 and 6. Vertex is here. Again, this is the lowest point, and it is 1 and 2. Here it's the highest point, and it is in your vertex, and it's -3, 4. And right down here is the final one, and it is 0, oh no, -4, 0. So what you should notice is that in the vertex, the x value is the same value as your axis of symmetry, right? So -4, -4, -3, -3, 1 and 1, 4 and 4. So that's one thing to keep in mind. The y-intercept we should be familiar with it. That is where it crosses the y-axis. So that's our y-intercept, and it has the value of 0, 2, and crosses here again. It has the value of 0, 4. Right here, 0, -5, and finally here, 0 and 16. So those are our y-intercepts. Again, that should be fairly straightforward. It's where it crosses the line. And finally, our x-intercepts, or zeros. Now the x-intercepts are similar to the y-intercepts. It's where it crosses the x-axis. Another term for it are zeros. So if I look at the first one, I see my two x-intercepts here. So I have two of them. X-intercept of 9, 0. Again, it's just a point. Here's another one. X-intercept of -1, 0. In my second graph, this one here, there is no x-intercept because as you can see, the lowest it goes is the vertex here, and it does not cross the x-axis. So we can just say there's no x-intercepts. But we can see that visually just by looking at it. Here, again, we can see two x-intercepts, 2 points where it crosses the x-axis. So -1, 0. And here is another one. Another x-intercept, -5, 0. And lastly, on this last one, this one is going to get a little bit crowded, but there is an x-intercept. There is only one, and it's where the vertex touches the x-axis, which is -4, 0. So we've seen 3 different examples. One where we can have, or 2 where we can have 2 x-intercepts, 1 where we can have no x-intercept, and 1 where we can only have 1 x-intercept. All 3 cases are allowed. They are characteristics of a quadratic function. It just depends on, as you can see, the orientation and the shape of it. So looking at that, let's get into our note on quadratic functions. So basically, we're just going to go through and highlight some key things. So the graph of a quadratic relation or function is called a parabola. Right? So a parabola is that U shape. And there are some important kind of features that we need to look at, and we kind of did that with the last one. We want to be able to identify our axis of symmetry, our x-intercepts, our vertex, and our y-intercept on any given function if it's graphed. So our y-intercept, you can easily see it's where it crosses the y-axis. So in this case, it is 0 and 5. Our axis of symmetry, again, remember, is that vertical line that cuts our parabola in half. In this case, it's x equals -3, because that's the equation for a vertical line. Our x-intercepts, where it crosses the x-axis, so -1 and 0, -5 and 0. And our vertex, again, is either that lowest or highest point. In this case, it is -3, -4 is our vertex, because that's that lowest point. So again, those are the kind of key things that we're looking for. Other things that we want to know, and again, this can be general review. Parabolas can open up or down. So again, we've seen both examples that up is when they open up like this. So the opening of our parabola that I'm going to draw in red, the opening faces up, and when it faces down, we kind of get that N shape, because again, that opening drawn in red faces down. Zeros, we've talked about zeros. They're also known as the x-intercepts or the roots. So depending on your question, you may see any one of those terms, and they're all interchangeable. They all mean the same thing. The axis of symmetry we talked about divides the parabola into two equal halves. The vertex of the parabola is where the point where the axis of symmetry and the parabola meet. So we talked about how the axis of symmetry cuts it right in half, goes right through the middle, and it can also be considered the maximum or minimum value. So that's key there, because especially when we get into application questions. The optimal value, so again, this is more related to application. The optimal value is the value of the y-coordinate of the vertex. And again, the y-intercept, we know where the graph crosses the y-axis. So those are just some key things that we want to know, or we should keep in mind about parabolas. What we're going to do now is do a quick overview of the three different types of functions, or the different versions or forms of the quadratic functions that we may come across in this course. So the first form is the standard form, which is y equals a times b to the power, or a times x to the power of 2 plus bx plus c. So that's your standard form, or that's what's considered standard form, and it gives us two pieces of information. The c value tells us the y-intercept, or the initial value. And we should know initial value also means like starting value, again, depending on what the scenario is, but generally in every case it's the y-intercept. The A represents what we call the step pattern. Again, that may be familiar from last year, but the step pattern, we'll talk about it below. The step pattern is basically follows the pattern of 1A, or 1 times A, 3A, 5A. So those are the only two pieces of information standard form gives us. Factored form is another form, and we'll look more in depth at this later. But factored form, again, has two things. It has the A value, and the A value, we can just take this exact same thing that we copied up here and put it down here. So the A value is, again, the step pattern. And you're going to find that in every form, the A value means the exact same thing. So if we have to change forms, the A should be the same throughout. The R and the S value in factored form, R and the S represent your x-intercepts. Are your x-intercepts, or your roots, or your zeros, any of those terms. One thing to keep in mind, though, you may want to note this: opposite signs of what you see. So if you see an equation where there's a positive R and a positive S, in actuality, it means it's a negative value, so it's a negative x-intercept. And again, we'll look more into depth at that. Vertex form gives us, again, three things in this case. For A, I'm just going to copy the exact same thing. It's still the step pattern. Actually, I'm just going to go back and highlight those. So A is the step pattern. H represents the x value of the vertex. So in our vertex, we have an x and a y value because it is a point, but the x value is represented by H, and again, it is the opposite sign of what you see. So similar to the factored form, if it's the opposite of what we see. And finally, k. K is the y value of the vertex. And it's just as is. So whatever the k value is, that's the y value of the vertex. So we'll put over here another thing, vertex form. Basically, it tells us the vertex in the form hk, because h was the x value, although the opposite, and then the k is the y value. So vertex form, hence the name, gives us the vertex. Now, every equation or every form of the quadratic function gave us a step pattern. And what the step pattern is, it's a general formula that helps us go from one point to the next. So basically, the general formula that we've mentioned is 1a, or 1 times a, is our first step. (3a) is our second step. And 5a is our third step. So what that means is, in general, basically to use that step pattern, is I start at the vertex, I go over 1, up, however many that first step is, that's 1 point. So this right here, 1 point. And then I do the same thing again. From that point, I go over 1, up, whatever my next step is, that's my next point. Over 1, up, whatever the next one is, and that's my next point. And we can kind of see an example of that here. Looking at this equation here, I can see my step pattern, my a value. My a value is 2. So if I wanted to do that as a step pattern, my step pattern would be 1a, 3a, 5a, or 1 times 2, 3 times 2, 5 times 2, which just works out to 2, 6, and 10. So if I look at this, at my step pattern, or it's already graphed out here, I start at the vertex, I go over 1, and I go up 2. So that's my next point. From there, done in purple, I go over 1, my next step is 6, so I go up 6 to my next point. And finally, my last one, I go over 1 again, it's always over 1, and this time I go up 10, because 10 is my third step. So that's how the step pattern works, and it would work the same way on the other side as well. Go over 1, up 2, there's a point. Go over 1, go up 6, there's a point. Go over 1, up 10, there's a point. Again, lines are a little bit off, but you can get the general idea of the step pattern. So again, it follows a 2, 6, 10. So that's general what the step pattern is. So that helps us find the a value, or identify what the a value is. So from that, what we're going to do is we're going to go into a little bit of practice. So I'll go through the first couple examples, but a reminder, we're going to try to find the vertex and the factored form. Those are the easiest forms to find. So given our first parabola, I want to know what the vertex is. Vertex is, again, the lowest point or the highest point. So here's my vertex right here. And the vertex has a value of, or a point of, -1, -8. So the first, my vertex is -1, -8. My roots are also the x-intercepts, so I'm looking for them here. So we have 1, 0, -3, 0. So, or not my y-intercept, sorry, that's my x-intercept. So I have two of them, so I can list them as -3, 0, and then 1, 0, or I could just list them as -3 and 1. However, don't put brackets around this like you see here. Do not do that, because then that may get people confused and think it's a single point. The step pattern, again, the step pattern, remember how we figure out the step pattern is we have to look at our graph. We're going to start at our vertex, and we're always going to take one step to the left or the right. Either way, it doesn't matter. Remember, it's symmetrical. So I'm going to take one step to the right, and then I'm going to go up 1, 2. So I have a step of 2, and that's where I hit my first point. To figure out the rest of the step pattern, I'm going to go over 1 again, go up 1, 2, 3, 4, 5, 6 to get to my next point. So that's my next step. And finally, go from that point and then count it all the way up again, and we have a step of 10. So that means my step pattern is 2, 6, 10. Now the helpful thing with this, the step pattern helps us figure out what the A value is. If we remember that the step pattern is 1A, 3A, 5A is the general pattern, that means 1 times whatever the A value is has to be my first step. So my first value or my first step is always going to be my A value. So even if you can't figure out the rest of the steps, as long as you get the first one, it'll always tell you the A value. All right, so we need our two equations. Again, vertex form, y equals a, x minus h squared plus k. And the factored form, y equals a, x minus r times x minus s. Slightly different from what we saw, but again, as long as you recognize that the signs are the opposite. So let's start with our vertex equation first. Y equals a, which we know is 2 from the step pattern. X stays general, minus h. So in this case, remember your vertex is hk. So my vertex, I should be minusing h, or if we remember, I should see the opposite of whatever h is. So I'm going to see plus 1, even though my vertex is minus 1. And then my k just stays the same. So that's my vertex form. My factored form, y equals a, which is 2, x, and then my 1x intercept, but the opposite. So in this case, plus 3 times x, and then my other x intercept, but the opposite, so minus 1. And that's your two forms. We'll go through the second example just to kind of confirm that. So again, in the vertex is again the maximum or minimum point. So here is my vertex. It has a value of -3, -6. My roots or my x-intercepts, this one's a little bit hard to tell, but we can roughly say, let's say it's about 0.5. So -0.5, 0, and -5.5, 0 are my two x-intercepts. Again, we're just estimating based on what we see. And our step pattern, we see we go over 1, up 2, or sorry, over 1, up 1. So that first step is 1, then we go over 1, up 3. We go over 1, up 5. So our step pattern is 1, 3, 5. And we can see that this doesn't change from our original 1A, 3A, 5A. And looking at that first value, we have an A value of 1. So let's put this together into our two forms, our vertex form and our factored form. Our vertex form, if you remember, y equals a, so in this case 1, then in brackets x minus h, so because h is -3 from our vertex, that means it should be +3 in the equation. and then our k value just stays the same. So our vertex form y equals 1, x plus 3 squared minus 6. For the factored form, again, y equals a, which is 1, x minus our first x-intercept. So in this case, it's minus negative 0.5. So I should see a plot positive or the opposite. And then x plus 5.5. Again, you should see the opposite. So again, those are two examples of going through, looking at two graphs or two quadratic functions and identifying what the two functions or the equations of the functions are in the two different forms.